Dr. Knag.
Dr. Bilo.
And what now?
Right. We engineered nicely our system. We had opportunities of aluminium, wood or steel, like you see over there. And now it's finished. Now we can go for a tender process. If not, we have a request of, say, showing alternative solutions. So what are the alternative solutions next to the 3 different materials which we may go for? So if we develop this as a stick system.
Stick system, actually, or post and beam facade. We come to the building site often as pre-manufactured ladders. And then on the building site you put them on place and you connect them with additional transoms, and that is then the grid, the facade system, the stick system that has to be glazed after the entire grid is assembled. So therefore the glass comes afterwards.
Alternative, unitized system.
What is a unitized system? So in principle is cutting the facade mullions and turns them in half, creating a frame out of that, and then you can assemble the facade as brick by brick on top of each other. So what you do is you pre-manufacture these facade frames or units already at the hall or production manufacturing facilities from the facade contractor, and they already include the glazing and the sealants and the sunshades maybe even, and they bring these fully assembled units to the building site, and then you can stack them next to each other and then on top of each other.
So if you go for the normal stick system detail, which we already know
it's a standard.
a lot, so yeah, here we go.
And then
glass, fixed,
cover cap,
screw. If you go for a unitized system, what do?
Yeah, they cut the mullion and the transom in half. To create a frame with the left or right side member. That becomes the unit. So this is like a box.
One unit,
Precisely.
this kind of box, and this is the next one,
Yeah.
and then this has to be sealed. So we have 1, 2, 3 layers of sealant which are brought in position. We saw that in aluminium, wood and steel. We are aware of, say, an aluminium version, like this.
Yep.
But we are also aware of, let's say, a wood version of this, which means this is actually made out of wood.
Yeah, and they also have this little
interlock
gaskets to connect to each other that you're also able to create these 3 layers of defenses, moisture, airtightness.
So, stick system versus unitized system.
Unitized system often used if you have a lot of same elements, and then you can speed up the process because you already have everything installed. Often also increases the quality. It's a logistics issue that you have to make sure that you can hoist them into place. Wind is an issue, but often it's the better solution whenever you need high rises, for instance, facade.
Now, alternative, somehow I wanted more free form in the facade. So I can imagine a stick system. And
so you twist it or bend it.
Somehow I make it 2-dimensional, like this.
So it's kind of like, it really is a free form shape of the building.
It really gets a free form shape of the building. So may this go through, and this may find a geometry like this. And the consequence, this is kind of bouncing out.
We show a couple of pictures of facades.
So, again, this standard detail. And now I'm trying to draw this 3-dimensional. So we have the facade stick system. We see this being the normal intersection as we saw it in the showrooms. And now this one needs to be 3-dimensional. So we either have the solution of using a stick system and whatever kind of wild angle something cutting into, which means it has to have a different interface in here. System
it's kind of like compound miter shift, miter angles. No?
Yeah.
It's a tricky part. You have to know exactly the geometry, and then you cut them under 74 point whatsoever degrees, and then you have to put these together. It's tricky.
As long as the system allows
Yeah.
to have certain angles.
Precisely.
If it gets super sharp, if it gets not only in one line but in the other geometry as well,
Forget about it.
then you may end up, oops, and that's now a complex one. So let's see if I can draw this directly as, say, and sketch. If you would
end up
be,
with a note.
yeah, and then with a note. So if you would be able to cut rectangular here, making it even more complex to have another one here, we may need to find a solution to get this as one geometry node solved. Zack, zack.
So it's one note.
One
That
node.
connects perfectly 90 degrees straight cutted standard profiles, and the complexity of the geometry is solved within the node.
That's the idea. And that's an interesting one. Again, we're going to show some pictures here of opportunities of technical solutions. And it's either a 3D printed or out of the solid piece solution.
So additive manufacturing in this case makes sense because each of the different nodes are different.
Yes, that's
And
the
that's
point.
the beauty of the system,
That's
because
the point.
the 3D printer can print all of the individual parts with the same ease, let's say.
Now, final topic we'd like to address in this one. We again come with our stick system. And again, if I draw it two-dimensional, I'm aware of this is having, say, a certain dimension, like this.
Yeah, that's
The normal
what we already
stick
had
system.
for a few
Yeah.
weeks already now.
And if I'm now placing glass in front of it, this is, say, still the 50 mil, which is blind.
Yeah.
I can't see this. So do I need a stick system, or can I think of a pure glass structure, having glass plates in the size I'd like to have them in position?
So the structural use of glass.
Structural use of glass. So glass actually takes down the loads, but
Yeah.
horizontal loads needs to be taken care of as well. So we somehow need some kind of substructure at the back, which we, if we want to stay in glass and have full transparency, may. So if this is this detail, we may go to such a detail like here, and I may end up in, okay, I add a beam out of glass at the back, like this, and then this beam may be 3 layers out of glass, laminated glass, and then this may be sealed or with a hidden screw fixed.
Why do you use 3 layers of glass?
3 layers of glass. Interesting question. So when we look at this setup, this normally is also some kind of laminated safety glass. So if one breaks, the other one doesn't fail.
It's a safety effect.
It's a safety effect, and that's the same here. So we have 3 layers. If the one side fails and the other side fails, the inner one, entirely covered, still stays in position.
It's in principle the same like glass stairs.
Same like glass stairs. Yeah, same like glass stairs. So, alternative solution for our system in glass, alternative solution in free-form geometry, either milled or 3D printed.
Just to make sure, this is a complex development of the last couple of years. We've seen many PhDs also within our institute and colleagues of ours. So therefore, just be aware, this was a very quick explanation and a lot of things to be taken care of. So
Of course. And then there's an alternative which mainly is related to logistics or, say, site construction, getting into unitized systems versus stick systems.
perfect.
This is it.
Great.
Check.